cosine 2 theta plus another theta, because I have my identities that can help me with that. So I have my formula booklet open. If I use the cosine one of these, I figure that's going to be the compound angle. So 2 theta cosine theta minus, I think this is right. If that's plus, this is minus sine 2 theta sine theta. So the A and B and A done like that. Okay. I don't want double angles. I want single angles. They can be squared or cubed. So these are both single angles. One's cubed, the other's just on its own. This is 2 theta. I don't want 2 thetas. So I need to figure out a way of getting from a double angle down to a single angle. And I once again go back to my trig identities. And I have one for cosine 2 theta. And I'll use the one that's 2 cosine squared theta plus, is it plus 1 or minus 1? Minus 1. Minus 1 instead of this one. Why did I do that? Well, I can see that this times this is going to give a cosine cubed. So I like to look at that. For this sine 2 theta, don't really want sine 2 theta. The only option for sine 2 theta is 2 sine theta cosine theta to get rid of it. And that's going to be multiplied by that sine theta at the end. All right, not still looking too wonderful, but we're getting a little bit closer to where we want to go. Let's just multiply and see what happens. So that's 2 cosine cubed theta from this times this, minus cosine theta, this times this. Now I'm going to multiply this in, so that's 2 sine squared theta cosine theta. The sines will square. So now I look at sine squared theta, and I know that that can be transformed into cosine theta. Why do I want to do that? Because there's only cosine thetas in my answer. So what's sine squared theta? Well, it's 1 minus cosine, yeah. So that's from the Pythagorean identity. So let's put that in now. So 2 cosine cubed theta minus cosine theta minus 2, 1 minus cosine squared theta cosine theta. So that's from the Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. So I can rearrange that. Sine squared is 1 minus this over here. So tidy this up a little bit, and I'm hoping that it'll look like what I want it to look like. Multiply in again. Cosine cubed theta minus cosine theta. Now multiply this by minus 2. Minus plus, so 2 cosine squared thetas. That's that, but I haven't multiplied by the cosine theta at the end yet. So these, I multiplied just in by 2. That wasn't very, I didn't do that very well. I forgot about the cosine at the end. I'll do the cosine first. I think it's easier. Cosine theta minus cosine cubed theta. And then I multiply it by 2 afterwards. Whew. Multiply by minus 2. We're nearly there. Cosine cubed theta. I probably wouldn't rewrite all this out, but I'll do it anyway because it's easier to see. Cosine theta. On 3? Oh no. Where's my sign wrong? Plus 2 cosine cubed thetas. Let me just check where I've gone wrong with my sign. Something has to...
What's wrong?
No, it's right. Yeah, sorry. This one and this one means there's 4 of them. This one and this one means there's negative 3 of them. And that's what we wanted. Okay, so yeah, very difficult trig identities question to manipulate them just using the identities we know. Okay, so part B asks us to give it some other function. So this function, weird looking thing, 4x cubed minus 3x minus cosine 3x. Usually with a question like this, it's a follow-on. So why did we do all this and then just jump to this? Maybe you notice that x looks like it's going to be cosine theta or cosine something because I got 4x cubed and that's 4 cosine cubed. So we're going to use whatever we found here at some stage. Verify that cosine x is one of the roots. Okay, so even if you got the first part wrong, you can start the second part. So I would start this, okay, so it's one of the roots, a root, you sub it in, yeah? So f with cosine k in, Well, if it's a root, what should it be?
0.
Should equal 0. Okay, so let's see, does it? 4 times cosine cubed, or you can put in like this. K minus cos 3k. So we have this. We go, okay, is that going to be 0? Maybe. But do notice that this is the same as this, isn't it? Maybe I write it like that. That cubed can sit in here as well. Okay, so earlier on in the question, we just figured out that any angle like this equals this. We proved it for all angles, so for k it's going to work as well, that this is cosine 3k. And that's minus the 3k, so that equals 0, which is great. So yes, it is. All right, next one. Let the remaining two roots of f of x be alpha and beta. Find alpha times beta in terms of cosine.
Have you done these before?
K. Have I done these before? Yes. Why? Yeah. Yeah, so there would be more thinking time. It would take longer. Okay, so alpha times beta. Yeah, I'm thinking product, yeah. Find alpha times beta in terms of k. So the product of the roots from our formula booklet, if you go to your formula booklet, product of roots. Product of roots, you see this in your formula booklet, minus 1 to the power n a0 all over 8n. All right. So the coefficient, so the product of roots in general is, well, this is my function I'm looking at here. The a0 is what?
4.
No. It's the last term. Yeah, it's the constant term. So that's negative cos 3k. Minus 1 to the power of n, is that going to be negative 1 or just? It's going to be negative 1, yeah, because it's cubed. And a to the n, or a underscore n, it's not a to the n, is the coefficient of the first term, isn't it?
4.
Which is 4. So we have cosine 3k over 4 is equal to what? Well, I said it was the product of the roots. So alpha times beta times the other root we got, which is cosine k. So what's how can we write this? I think just divide by cosine k. Alpha beta is equal to cosine 3k over 4 times cosine k. When I did this,
But can you simplify it more by plugging in the formula cosine cube k minus b cosine?
Yes. So that's what I was thinking. This is back to this thing, which means I could be able to simplify this a little bit. Cosine 3x or 3k is this 4 cosine k cubed minus 3 cosine k all over 4 cosine k. So I think a cosine k can go into all of these 3. So we've cosine 4 cosine k squared minus 3 all over 4, which this 4 cancels with that one. So you can do it cosine k squared minus 3/4 if you want to tidy that up a little bit. Okay. Someone got that? Anyone get that? Yeah, a few of you. Okay. That's
Did you skip B?
we did B. Verify as one of the roots we subbed in. Okay. Part 2 then, show that.
Oh, this is just sum of the roots.
Yes. Yes. So for part 2, you got to think sum of the roots. And well, let's look at sum of the roots anyway. Sum of the roots formula. Well, what is it? What is the sum of the roots of this one? Yeah, minus b over a.
3 over 4.
Yeah, so that was the mistake I made. I had to go back. When I started, I went, that was wrong. I figured, I put in minus 3 over 4. Why is minus 3 over 4 wrong?
Because it's minus 3.
No, it's 0 over 4. Yeah,
You're missing a square.
because there's no x squared there. It's 4x cubed. There's no x squared, and there's x. So the sum of the roots is 0 over 4, which is just
That's so stupid.
0. It's not. Okay, we should know it's this, the x squared is the second term. It's not the second term if it's just written. It's the x squared term. Okay, or a to the n minus 1 term. That's what's in your formula booklet. Okay, so I know the sum of the roots is 0, which means adding up these three roots, alpha plus beta plus cosine k equals 0. And I think if I just rearrange them, I get beta is equal to minus alpha minus cosine k. Okay. All right, so that's that done. So we're on to part D now. Using your answer.
3 marks.
Okay. Using your answers for part C, show that alpha squared. So they say, right, you got 2 answers in part C. So that was your answer. There's one of them. And this is alpha beta, isn't it? This is the other one. Okay. Use these 2 answers to show this. Now, what is missing in that expression from these 2?
Alpha squared.
No. That's not beta. Beta is missing from both, yeah?
Are both missing from both?
Yes, so beta is missing. Beta is missing from this expression. Which means if I rearrange this so it's beta equals, that's what I'm thinking. I can let them equal each other. And then you're, yeah. Okay? Or I can sub one into the other. So if I sub this in to this one, alpha times minus alpha minus cosine k is equal to, so I sub this into this one, so that's equal to cosine squared k minus 3/4. I think that's probably the easier one to sub in.
I don't like alpha. It's so
Well, we're just trying to get it to look like that. Once again, this one, even if you weren't able to get it, you were able to move on to the next part. Well, you got to learn how to do that. You got to learn. When they give you an answer and you can't get it, just move on to the next part. They're giving you a bunch of answers during this question.
So it actually gives you hints.
Yes. It's always a follow-on. It's always a follow-on.
Yeah, but like I didn't see that.
And even if you didn't recognize that this is sum of the roots or whatever, you can use this. You can use this then for the next part. You can just use, if you don't recognize something, move on to the next part, and maybe you'll click later, leave it blank. But don't just stop the question when you've reached your first point of I can't do it, especially not if they give you more functions throughout. Okay, so let's just rearrange this. I think it works out quite well. That's negative alpha squared, negative alpha cosine k is equal to this. And then I just look at what way they want me to write it. Well, I'll just bring everything to one side. Bring everything to like this side and let the 0 on this side. So that's alpha squared plus alpha cosine k plus cosine squared k minus 3/4. If it equals this on this side, then it equals on this side as well.
Wait, is that not?
That's correct. You did that.
I think that's it. Okay, let's look at part E. Oh, razor's not great. Hence show that alpha, okay, this is where maybe we start to think, but it's quadratic formula, yeah.
Oh.
You see it, maybe the recognition minus something, one of these is plus, the other one is minus, they're both over 2, square root, maybe you see the quadratic formula, maybe you see that this is a quadratic, alpha squared, alpha, and then a constant, maybe you don't see that as an entire constant. So in this case, A would be 1, B would be cosine k, and C is this entire thing of cosine k minus 3/4. It's just some number. All right, so how do I apply? So minus B plus or minus square root B squared minus 4AC all over 2A. Sub in these values and hope for the best. So minus B is minus cosine k plus minus the square root of cosine squared k minus 4 times this mess of a thing. Cosine squared k minus 3/4. All over 2 times 1, which is just 2. So we're getting close to the answer already. All right. Let's tidy up what's under the square root. So that's square root cosine squared k minus 4 cosine squared k's minus, I think this is plus 3, is it?
Wait, sir, you forgot to square the cosine squared k.
No, I did already. B was just cosine k.
Oh, sorry.
Yeah. All right, and that still has the minus cosine k out here, plus minus all over 2. All right, I want to tidy this up again. So I get root negative cosine, 3 of them, isn't there? 3 of them. There's 4, and then there's, negative 3 cosine squared k's plus 3. Now I look at what I need it to look like. And I think I need a sine in here, not a cosine. So what relationship has cosine to sine? Cosine squared. Cosine squared k plus sine squared k is equal to 1, Pythagorean identity. Or theta, or whatever k is. So if I want to write something instead of cosine k, I want sine in there. So sine squared k is equal to 1 take away this. Well, if I had this written somewhere, that'd be nice, because then I could just say that was sine 2. So Z sees it. Right, how do I get that to look like that? It kind of looks like it already if I just swap it around. If I wrote this the other way around, which I'm going to do now, 3 minus 3 cosine squared k. So it's just 3 times that. 1 minus cosine squared k. It's going to factor out the 3. So that's sine squared k. So that's plus minus 3 sine squared k, because this is that. We just showed it here. And now I have it. Minus cosine, this was always minus cosine k, I just didn't write it. Plus minus the square root of 3 sine k, because sine squared k is square rooted, all over 2. This was all over 2 all along. I think that's all we need to find, is it? Yes, okay.
That's crazy.
Now, continue. Let's get the last bit of the question done.
This is like the hardest question you were going to give us, right?
No, you'll get another hard one in the exam.
Yeah.
As I said, there's a difference. Objectively, now as you see this, you're probably not thinking it's that hard. Maybe some of you are thinking it's really hard still. But there was no step where you've gone, oh, there's nothing that you haven't taught us that, or I've never seen that before.
Yeah, but like,
It's just putting it all together can be difficult. It's going to be something like this, and you're going to go, oh, that looks crazy. And then if you just do it step by step, or skip the bits you're not sure and move on, keep moving on, you'll get enough attempt marks or marks to get a 4 or 5, and then people who understand it will get a 6 or 7. Okay, let's do this last one. Hence, find all the values of k. So it is known that k is between 0 and 360 degrees, so 1 rotation. The function has either 3 distinct roots or a single root and a repeated root. So this is a cubic function. You can see it's x cubed. So it's x cubed can be like that with 3 distinct roots, yeah? But I think it says for this particular one, it only hits the x-axis 2 times. So that will have to be 1 repeated root. That would be something like that.
Wait, does it say either? That's either.
It says either, but then it says, hence find all the values for which f of x intersects the x-axis exactly 2 times. Yeah. So if k was different, it would have a different set of values, yeah.
If you would
Different
draw
set of
that
roots.
on the unit circle for k has to be in between 0 and 180, and then k also has to be in between 180 and 360.
wait, why?
No, k can't equal 0 or 180.
I'm not sure yet. Why'd you say that?
Because if it was 180 or 0, it would just always be,
Oh, it didn't.
it would always be that line.
It'd always be just a straight line. No, it'd all be on the line or
Yeah.
one root.
It would always
It's possible.
It would always be 0.
I think there's a bunch of answers. Right. So we have alpha and beta, don't we, from earlier on in the question? This again, you could have answered without doing any of the rest of the question. You have alpha, so you have some of the roots. Remember, these are the roots. We have alpha from this as we just figured it out, but also they gave it to us. We have beta as this. One of them is, I think I have them the right way around, do I? Yes. What was the other one?
Cosine K.
Cosine K. And the other one, whatever you want to call it. Other one. It's cosine K. All right, there are 3 roots, yeah? 3 roots, not too sure what they are. How do I get this case?
Make
Wait,
one
one
of
of
them
them-
equal the other.
Yeah.
Yeah, so which ones though?
Not alpha and beta. Alpha
Could
and
be
beta.
alpha beta. Could it
Well,
be-
I'm just going to call this omega for now, just for a different sign.
Can we call it? Can we
So if alpha equaled beta, that could happen, yeah? That'd be one way. And then omega would be the other one. This would be omega, and alpha and beta would be a repeated root here. Or you can go alpha is equal to omega. Yeah?
Wait, how do you really know which one?
How do you know what?
He's going to get to that.
Or you can go beta is equal to omega.
So it's only alpha equal to.
So we have to look at all 3 of these cases. That's why it's 8 marks. We have to look at all 3 because one of them has to equal the other, has to be a repeated root, and then the other. If alpha equals beta, then omega is the other one. If this one, then beta is the other one, and if this one, alpha is the other one. For this case to happen, these 2 are equal, or repeated roots, it's called. Yeah. So this is hard to get your head around. It was really difficult. So I have to do it for each case. So let's look at case 1. Let's call this case 1, case 2, and case 3. Yeah, I know, it looks pretty bad. So let's do case 1 first, where these 2 equal each other. So minus cosine k plus root 3 sine k all over 2 is equal to this, the same, but with opposite, with a different sign here. Root 3 sine k is equal to 2. Okay. Solve for k. Now, there's a lot of things here that if I multiply both sides by 2, the 2's disappear. Yes? If I bring everything over to one side, these cosines are going to cancel each other out. Bring everything over here. So what am I going to get? I'm going to get the cosines cancel out because they're both the same side. This was plus, so there's going to be 2 root 3 sine k's are equal to 0, yes? So that means sine k is equal to 0 divided by 2 root 3, which is 0. Where is sine equal to 0 on a full 360 degrees?
0 pi. 0 pi and 2 pi.
0, pi, 2 pi. Or because this is in degrees, this question, 0, 180, 360. That's case 1. We got to do the other 2 as well.
What?
Okay. Case 2,
I don't get it. Wait, what's 0, 180?
there are the values that make those 2 equal, make those 2 roots equal. If k is those values, any of those values, then this alpha will equal beta,
So there's
and therefore it's a repeated root.
At least there's like 6 answers for 9 answers.
Yeah.
Okay.
But now we don't know if there's 9 answers because we're not sure.
All the values of K.
We're going to let alpha equal cosine k to see what values for k would make this one the same as each other. So this is alpha from over there is equal to cosine k. Multiply over by 2, yeah? So I get minus cosine k plus root 3 sine k is equal to 2 cosine k. Any ideas? How to solve this? No? Maybe at least combine the cosine k's together. Sine k is equal to, add that one over here, I have 3 cosine k's. Sine and cosine, the same trigonometric thing. What am I thinking? Root 2 over 2. How am I thinking that? I'm thinking tan. Sine and cosine, the same sentence. Like this was just sine, so I didn't have to do anything. So I'm taking tan, so I divide both sides by cosine k. Divide both by the same thing. This is just 3, and this is root 3 tan k is equal to 3. Divide over. Tan k is equal to 3 over root 3. Now 3 over root 3 is one of our known ones. If I conjugate not conjugate, whatever you call this, I can't remember.
Over 3.
Root 3. So tan k is root 3. Where's that a reference angle?
60 degrees.
60 degrees. So it's positive. Which two quadrants?
No, it's 30 degrees. Top right, bottom left.
No, root 3 I think is 60 degrees.
It's 60, I just.
60, yeah. 1 over root 3 is 30. You can, yeah, okay. So which two quadrants is tan positive? Because we've got a positive answer here and bottom left. So this answers k is 60 degrees. And what's this one?
180 plus.
Yeah,
240.
240. Very good. All right, so we got 3 answers here, or 2 answers here, 3 over there. We got to do one more case, and that's this one. Beta equal, which is pretty much going to be the same thing. How similar is it going to be?
Very similar.
Pretty similar.
What's my answer going to be different by? That's going to be minus, which means that's minus, which means this is minus, which means this is minus, which means that's minus. So it's just the other one. So tan, for case 3, if you want to do it quickly, tan k is negative root 3. So that's the other two.
300 and 120.
Uh,
300.
120 and 300.
360
This one, 360, 2 pi minus. Yeah. Okay. And that is your 8 marks. So the hardest part of that was probably figuring this out, which was